Alright, you are watching this video because you've been working on the combinatorics practice and you're running into some problems. Generally speaking, problems 1 through 8 are not terribly difficult and they're not really fancy at all. They're very similar to stuff we've done in class, so really check your notes up on that one. You'll find that the examples are not terribly different. But this one here is tricky. I prefaced this problem by saying it's tricky because I feel like it's tricky. So the first thing with this is a lot of folks are going to read this and they're going to freak out. They're going to see this big, long paragraph and they're going to say to themselves, well, this is too long. Just forget it. This is not going to work because for the SOL, you're going to need to get used to reading big, long questions like this. So it's going to be really important that you kind of hone in on these big, long problems and learn how to do them yourself. So first step really in this whole thing is read the whole problem. I can't emphasize whole enough. Don't just read the parts that seem important. I mean, it's a math question, so you'd think, all right, look for all the numbers. But if you just look at the numbers, this seems very jumbled and it's not clear what needs to happen. All right, so for Rachel's challenge, we're trying to create a street team to represent the core values. So we decided to choose 4 seniors, 3 juniors, 2 sophomores, and 2 freshmen. All right. So these are the number of choices we have to make. So we have to have 4 seniors. Okay, we have to have 3 juniors. We have to have 2 sophomores. And we have to have 2 freshmen. Alright, now we have 6 seniors. So what's going to happen here is we have this pool of 6. And I really like drawing pictures here. So there's 6 seniors in there. I have 5 juniors. Okay, and so there's the 6 seniors there. Here's the 5 juniors. Okay. 4 sophomores, and 5 freshmen, which are going to apply here. So we've got a lot of folks that are applying. Okay, and we have to have 4 seniors. We have to have, so we're going to choose 4 seniors. We're going to choose 3 juniors, we're going to choose 2 sophomores and 2 freshmen. So let's start figuring out what we're doing here. Well, let's start with the seniors. Alright, so let's do the seniors in red. What I'm going to do is choose 4. So let's say I choose these 4. And let's say I choose them like 1, 2, 3, and 4. Okay, so really what we know here, we don't know in terms of it's either going to be an NPR or an NCR. So we're going to try and figure that out first. So whether it's a C or a P, we don't know. So I'm just going to go ahead and put a little space there. But we know the N value, right? There's 6 people here. It's going to be 6. And I know I'm choosing 4 of them. Now the question becomes, am I going to be doing a combination or a permutation? Well, alright. So we chose 1, 2, 3, 4 here. Let's say I chose 2, 1, 4, 3 this next time around. Is that committee any different? Well, no, it's not. So instead of this space, I know what's going to go there is a combination. Alright, so now that we've done that, we know kind of what's going on here. We know that there are 5 juniors. So of the 5, I'm going to be choosing 3 of them. And then there are 4 sophomores. I'm going to be choosing 2 of them. And there are 5 freshmen. I'm going to be choosing 2 of them. Alright, so what I'm going to do is I'm going to divide this up. I'm going to kind of divide and conquer. So the first part, the seniors, I'll do that in green. Alright, so we'll do this calculation here in green. The formula for the combination, okay, I know NCR is equal to N factorial over R factorial N minus R factorial. Alright, so now I do the same thing here. So now I know my N is going to end up being 6. So since my N is 6, that's going to be the thing that goes up top. Where's my mouse? There we are. So I know I've got 6 factorial, which I know is 6 times 5 times 4 times 3 times 2 times 1. And all of that is over, well, the R is 4, so I've got 4 times 3 times 2 times 1. And then N minus R, well, 6 minus 4 is 2 times 2 times 1. Alright, well, it's pretty clear here that I don't need to worry about the 1s, so I can just totally get rid of those right out of the gate anyway. And now I start canceling things out. Well, alright, I see a 4, that's going to go away. I see 3s, that's going to go away. I see a set of 2s, that's going to go away. And what I end up with is 6 times 5, which is 30, divided by 2. 30 divided by 2 is 15. Alright, so I know that that is going to end up being 15. Alright, so the number of seniors. So the number of seniors is 15. And now, I'm going to go ahead and figure out the number of juniors. Well, with juniors, we'll do this one in purple. We're going to do that same type of thing. 5, 4, 3, 2, 1. Sorry about the smudge there. Divided by, well, R factorial. R is 3. 3, 2, 1 times N minus R. 5 minus 3 is 2 times 2. And I'm going to start crossing things out. Boom. 3s are gone. 2s are gone. Well, 1s, they kind of went away anyway. So now I've got 5 times 4, which is 20, divided by 2. And that's going to end up being 10. So I know that there's going to be 10 here. So number of juniors. Well, that's going to end up being 10. Alright. Sophomores. This is a much easier calculation. Requires a lot less fancy footwork. We'll do that one in blue. Well, a light blue. And here I've got 4, 3, 2, 1. Okay, obviously all of this is being multiplied over 2, 1. Well, 4 minus 2 is 2, so now I have a 2, 1 again. Okay, so now I'm going to start canceling things out. Well, what I could actually even do is just boom, boom. 2 times 2 is 4, so I can cancel that out. So now that obviously, the 1s go away as well. So now I've just got 3 times 2. That's going to end up being 6. So there's 6 sophomores. And freshmen, those losers, We'll do freshman in orange. Okay. Well, now I've got 5 up top, and 5 times 4 times 3 times 2 times 1, double smudge, sorry, divided by r factorial, 2 times 1, 5 minus 2 is 3, 3, 2, 1. Alright, and then what I'm going to end up doing here, do my canceling, 1s, they go away. The 2's go away, the 3's go away. So now I've got 5 times 4, which is 20, divided by 2. Well, that comes out to be 10. Alright. So the number of freshmen, there's 10. Now, what I want to know is the number of the total number of ways that this committee can be chosen. So now I have to take all of these numbers there and multiply all those together. Because I take the number of seniors and I multiply it by the number of juniors and I multiply it by the number of sophomores and the number of freshmen. I don't have a calculator in front of me, so I'm just going to do this in my head if you don't mind. 15 times 10 is 150. Times 6 is 900. Times 10 is 9,000. There are 9,000 different ways we can choose this committee. Now, it does not seem obvious at all. But using the process that we just walked through here, really all you did, and if we think about this, for what it is, all we ended up doing here is breaking this problem up into, we only did 4 problems really, and we just kind of smashed it all together in the end. So really what we're talking about here is we found this thing first, and then we found this thing, and then we found this thing, and then we found this thing. Now the fact that we multiplied them all together, well, we're now looking at a 1, 2, 3, 4. Then we multiplied them all together. That's a 5-step problem. So really what we're talking about here is 5 steps. The first 4 were actually really easy problems. How many ways can you pick 4 out of 6 where the order doesn't matter? Same thing here, with only we have different numbers obviously. Same thing here, different numbers. Same thing here, different number. So it's really just 4 easy problems, and you take their answer and you multiply them together. That's really it. That's really all we're doing here. So this is not terrifically fancy, and this is not anything that should be new and foreign and crazy to you guys. This is the type of stuff that you need to be capable of performing in this class. So this is a popular type of problem. You should definitely know how to do this. My tip to you in this one would be study this problem. Study this problem, because I guarantee it, and I cannot be more obvious about this, these types of problems are not going away anytime soon. Alright, thanks for watching. I hope this was helpful.